Hello, Cardinals. We're going to talk about investigation 3.2 today, modeling the water cycle on Earth. And our essential question is, how does the amount of water change in a closed system if it changes state? And refute is a vocab word today. It means to prove to be wrong. So before we start investigation 3.2, we want to take a look back at investigation 3.1. So you're going to look at your student sheet in which you should have made observations. And we want you to use the word bank here: cloudy, cloudy with small drops, cloudy with big drops, cloudy with water running down inside, and just kind of revisit your observations and add to, change, or modify what you wrote yesterday. And then we're going to talk through the lab step by step, because this is a very important concept, the idea of evaporation and condensation. So on the left side, you have a warm water 2-liter bottle, and on the right side, you have the cold one. And what you should have noticed is cloudy with large droplets on the warm water one, and maybe a little bit of cloudy with tiny water droplets. Some groups had none, but there should have been a definite difference there. So the warm water represents the warm ocean, and the cold water represents a cold ocean. And over warm water, there's more condensation. Over cold water, there's less condensation. So the question is, how did the water get to the top of the bottle? Well, it rose. You can't see it rise. You can't see it evaporate. You can't see it, but there's a lot more from the warm water and a lot less from the cold water. It evaporates. Evaporation is the process by which liquid turns into gas or water vapor. The steps work like this. Liquids gain energy from its surroundings, and then the molecules move faster and faster and faster and get further apart. And they become less dense, so they become a gas, and that gas rises, as you can see on the right. So now on to step 2 of the lab, we rubbed ice cubes on the top of the containers. What should have happened is you should have gotten more condensation at the top, more over the warm water and more over the cold water. So once again, the warm water represents the warm ocean. The cold water represents the cold ocean. The ice cube allowed us to have a cool atmosphere in our container. So we cooled down the atmosphere. You cooled down the air in the top of the container. So the question is, why did the bottle get more foggy? Well, it's called condensation. And condensation occurs more when it's cold. Condensation is the process in which gas or water vapor turns into water liquid. It's the opposite of evaporation. So because you cooled it off, that liquid lost energy. The molecules moved slower. The molecules became closer together, and they became little water droplets, and then that liquid sinks, it drops. So then the final step was when you placed your hand on top of the container. Once again, the warm water represented the warm ocean. The cold water represented the cold ocean, and your hand represented the warm atmosphere. You were warming the atmosphere. So it was the opposite of the ice cube. Your hands should have warmed it. So why did the bottle turn clear, or at least less clear, maybe a little bit less condensation? Well, evaporation happened. Your warm hands caused those little water droplets to warm up a little bit, and those evaporated back into the atmosphere of your bottle. It's called heat transfer. So heat transfer is when the surrounding areas cause an object to warm or cool, and that causes the heat is a flow of energy from a high temperature location to a low temperature. So that heat transfer caused the condensation to turn back into evaporation. This model was in your reading. This is something you're going to want to have in your book. You're going to have in your textbook. In your notebook. And it shows not only the water changing forms, it also shows arrows that represent heat gained and heat lost. So this is a big idea. So up here to the top right, evaporation happens when heat is gained. Condensation happened when heat was lost. So we want to write using our little sentence frame here. Warm water evaporates blank, then cooler water because blank. We want to use the word faster, slower, or at the same rate to fill that in. We have a little water cycle we're going to talk about today. Talk about where different parts of the water cycle happen in our atmosphere. And during our lab, we're going to be simulating a water cycle. So you're going to be setting this up in the lab. You're going to be using some small measuring cups. You're going to have a student sheet to record your data where you're finding the mass of different containers, some with ice, some with water. And you're going to add all those masses together with the water, the mass, to record the total. And you're going to place the measuring cups in a container, and that lid's going to get sealed, and you're going to place that in front of a light for the next 24 hours. So the language we're using, a lot of things, it's going to be procedure language. So the language allows us to do certain things. So you're going to look at the different titles for each section to help you. And what you're going to be doing is organizing the text. So just as you see the text today, you're going to want to maybe highlight or underline the directions that you're doing. So to do this today, we are investigating 3.2, modeling the water cycle on Earth. You're going to be setting up a lamp, doing a lot of things with mass and recording the mass of ice and water and adding those all up. And you're going to be recording some detailed observations, and that will be placed underneath the light source. If we get time today, you're going to want to read through part 2, that's tomorrow, and then start reading Building Your Knowledge, the water cycle from the sky to the land and back again. So if you have any questions, ask your teacher, and have a great day, Cardinals.